Hey, what's up, I'm Marvies. Welcome back to the commute. In this video, we're going to be exploring the internals of a view model. If you are an Android developer, you must have used view models in your production level code. So I have right here a simple declaration of the view model. Let's try to understand how is it working and how are we actually declaring and what is going on. Okay, looking at it, we have a simple variable called tree view model of type of home view model by view models. Okay, now the home view model is a simple class. As you can see, it's a simple class that extends the view model class itself, right? The actual abstract class of view model, right? And this is something, right? Now what is this by and what is this view model? Okay, if you do not understand what is happening in this declaration, let's try. Okay, let's try to understand this declaration. The by simply means that the functionality of this view model, home view model, is provided by something, right? So this is what basically by means. By the view model function. This is the function. This is a function, view models function. As you can see, if you can hover over it, you'll see that's it's an inline function. Okay, so its implementation is provided by the view models function. In simple words, you can understand by keyword as provided by. When we use by keyword, you're stating that the getter and setter is provided by elsewhere, not by the val and set and stuff that is already present inside of the Kotlin. You're saying that it is provided, the getter and setter is being provided from some else location. So we can say that the definition of home view model is provided by the view models function. So where does this view model function come from? Where is it coming from? Is it some kind of object somewhere, class somewhere that we're getting this home view models function from, right? If we were to look inside of the view model function, let's try to look at, right? If we were to look at inside the implementation of the view model function, we would come across two functions. We have the component view model something. This is a type of function, right? Now component activity dot view models is some function, right? There are two different functions right here. So what is happening here? That this view models function actually extend the component activity. And if we were to look at the component activity, as you can see, this component activity is the same activity which main activity extends. So that's how this view model functions is being provided here. Hope you understand that. The component activity itself has all the implementations of the view models. For example, view model store owner has default view model store provider. Let's try to look at the functions inside of this. The two functions right here. They're two different functions, pretty similar, but different things are being passed through their constructors. Let's try to understand and break them down. Let's try to look at this particular function first. What we have here is a main thread. The annotation ensures that the function runs on the main thread, which is critical for the Android for UI components like viewmodel. Simple as that. This function just simply runs on the main thread. Now, if you do not understand inline, I've already made a video around inline. If you do not understand it, here's a simple summary. Now, inline function meaning that the function body will be inserted at its call site. It means this whole function's stuff inside of its body is basically copied and pasted right here. Okay, wherever it is used. Okay, simple as that. Wherever it is used, the whole functionality of this particular function is just copied and pasted right here. Now we have a public inline function which has a reified type, reified of VM. Looking at the reified VM view model here, it is a generic type that extends the view model class. The reified keyword means that the actual type of VM can be accessed at a runtime. Normally generic types are erased, but with the reified keyword, Kotlin actually retains the type information. If you do not understand reified keyword and type erasure, you have to learn about those first before understanding how this this particular stuff is working. Now, as we have seen, the main thread runs on the main thread, a public inline function, reified VM. We are actually retaining the data type here. Component activity dot view model, view models. This function extends the component activity. Then we have some kind of no inline function here and a lazy initialization of VM. So no inline simply means that we are actually trying to use it in some kind of scope, the brackets that we use, right? And since we are inlining it, the parameter, the lambdas that we are using are not present anymore. So it will start to give us error. To avoid that, we are actually using no inline. Simple as that. Okay, let's try to understand what is happening here. Now we have a factory producer which is accepting some kind of function, right? As you can see, it is accepting some kind of factory, right? So basically, val factory promise is equal to factory producer, okay, of type of default view model factory. It means that if there is some kind of factory producer, we can use that. If not, then the default view model factory will be used. Default view model provider factory will be used. This is some kind of utility class view model lazy, which basically lazy initializes the view model. So view model lazy, this is a VM, which is the generic type that we are accessing. We are able to actually access it because it has been reified. Then we have a view model store, which is basically the storage place of where the view models will be stored. A factory promise, what kind of factory we are using, and some kind of extra creation. For example, save state handle will be passed, some kind of extra stuff that is being passed. So this particular function is being used to actually create the view model that we require. This function is pretty similar to the previous one. The only difference is that we have some kind of extra producer stuff right here, and we're expecting some kind of extra producer stuff and invoking it when needed. Okay, let's try to look at side of this default view model provider. As you can see, you've already come across this file. This is component activity. It means that if we were to highlight the view model inside of this component activity, we will see a lot of view models. It means that this particular component activity has all the implementations of the view model that we actually need, right? Let's go up. This particular implementation, what do we have here? A view model store owner, which is basically the owner of the view model store, which means the view model store is the place where the view model is stored while the configuration changes are happening. If you do not understand configuration changes, it simply means that when the rotation of the screen happens, the activity might die, but we need to save the state of the view model. So it is actually saved inside of the view model store itself. Okay, as default view model provider factory, this is the factory responsible to actually produce the view model itself. We have an internal class of non-configuration instances. Now this is a non-configuration instances class, and it is designed to hold the objects that need to survive configuration changes, such as screen rotations in Android activities or fragments. Let's break it down. Now internal keyword, which means that it is a visibility modifier, means that this class is accessible only within the same module, meaning it can't be accessed outside of the module where it is defined. This is often used to encapsulate the implementation of its detail. Okay, I hope you understand how internal visibility modifier works. And when we have another variable called var custom any is equal to null. Now this property holds any custom type. Any is the superclass of every class, so any means it can have any property or null. Okay, this is the purpose of the field, is to allow developers to store custom data that needs to survive the configuration changes. It's optional, hence it is set as null. Okay, then we have var view model store. View model store is equal to null. View model store is an Android class that holds the view model instances. The view model store property here is meant to store the view model object, which is crucial for managing view model instances across configuration changes. So this is a simple non-configuration instance which will actually store the instances when the configuration changes happens, and that's what exactly. Now as you can see, we have another view model store right here, right? Some kind of view model store stuff here, lazily recreated from non-configuration instances while view model store. Now what is happening here? The reason we have a separate private variable like view model store in addition to view model store typically relates to lifecycle management. It simply means that when the configuration changes happens, it might be that the view model store is actually cleaned up and we want to restore it from somewhere, right? From the previous non-configuration changes, we restore the view model store which has the view model instance of the previous configuration. So we want to get that. So that can only happen if we have some kind of variable to actually get it, right? We want to store it in the view model store. Private var view model store is equal to null. This is the variable that actually gets the view model store. Okay, I hope you understand the differences. Looking at this particular life cycle, let's try to look at this particular life cycle. First of all, we have a life cycle dot add observer, some kind of event observer. We're basically observing the life cycle. And we have if event is equal to life cycle event dot destroy, which means that if the life cycle is being destroyed, clear out the available context. The context aware helper dot clear available context. Now what does this mean? This line clears any reference of the activity or fragment context from context aware helper. Context aware helper is likely a utility class that keeps track of the current available context. By calling clear available context, you're removing any references to the context of this activity, which prevents memory leak, avoiding and holding a context that is being destroyed. It simply means that on destroy, please destroy the context of the activity or the fragment. Okay, now since the activity is being destroyed. If the configuration changes are not happening, it means that we are actually closing the app instead of actually rotating it. Please clear the viewModel store. Okay, if the configuration changes are happening, please do not execute this thing, and the viewModel store itself will not be destroyed. Now, looking at another lifecycle, we have lifecycle.addObserver, some kind of observer here. We have override on state change. If the state changes, right, ensure viewModel store lifecycle.remove any kind of observer from that. So whenever the state changes, it might be some kind of state has been changed. It means that the activity is maybe getting destroyed and recreated again. The state has been changed. If some kind of state has been changed, ensure the viewModel store. What is this ensure viewModel store? This basically ensure viewModel store is responsible for ensuring that viewModel is properly initialized. It means that what if the viewModel store itself is not present, right? We have to ensure that viewModel store is present and actually get it from the previous stage. For example, if the viewModel store gets destroyed, right, and it is actually present in the previous configuration when the configuration change happened, we want to receive it again. That's what ensure viewModel store is actually doing. We will look inside of viewModel store, okay, and we'll be able to understand how this particular function works. Now, this function is responsible to preserve the state when the configuration changes are happening. Now, what we have inside of this particular function is maintain backward compatibility, where custom on retain custom non-configuration instance. We have val custom is some kind of variable, okay, on retain on configuration instance. This is a custom implementation of on retain non-configuration instances. It means that we can also customize the configuration change instance. But the thing is, this particular function has been deprecated. As you can see, we are not allowed to do this, but it is still present with us because we want the backward compatibility when it was already present. Somebody might be providing some kind of custom configuration changes. This is viewModel store, okay. We retrieve it from the private viewModel store that we saw above. If viewModel store is equal to null, it might be that it is null. It has not been created. Okay, no one called get viewModel store. So if there is an existing one, viewModel store from the last configuration instance. Now we have this viewModel store is equal to viewModel store, the private variable that we explored above. Now we are actually transferring this to this viewModel store, and we see that if is equal to null. If it is equal to null, it means that no one called the get viewModel store. So if there is an existing one, the viewModel store from a last configuration instance, we try to get it. That's basically what this particular stuff is doing. ViewModel store is equal to null. It means that the ViewModel store itself is equal to null, and we want to get it from somewhere. Either we call it for the first time, or if it is present in the last configuration instance, we get it from our last instance of the activity before it was destroyed. Okay, the val nc last non-configuration instance as non-configuration instance if nc is not equal to null. Okay, get the ViewModel store that was previously present and give it to this thing. Okay, if ViewModel store is equal to null, if this is equal to null and there was no configuration instance, it might be that we are making the ViewModel store for the first time. Is equal to null and custom is equal to null, return null. Okay, looking at inside of the ensure ViewModel store, what do we have here? Okay, let's try to understand the ViewModel function, ensure ViewModel store function that we explored previously. Okay, now if ViewModel store, the private function, the private variable is equal to null. Okay, well, and see the last configuration as non-configuration instance, which means the last configuration of the activity before it was destroyed. If nc is not equal to null, it means that the configuration was previously destroyed. It might be there's some kind of stuff being saved in the last configuration. If nc is not equal to null, restore the ViewModel on the non-configuration instance. We just try to restore it, right? If the ViewModel store is equal to null, we actually try to create it. That's what this new view. There's a whole new active class being used here. If you understand ensure ViewModel store now, this basically ensures that the ViewModel store should be present when the lifecycle actually on the state changes. When the state changes, we ensure that the ViewModel store is actually present to store the ViewModel. Okay, it simply means that. Looking as override well default viewModel provider factory, viewModel provider dot factory by lazy initialization of state safe viewModel factory application. This intent is equal to 1. This basically means that it provides us the default viewModel provider factory that we use to create the viewModel for the first time. Hope you understand this thing. So this is it in the component activity side. We will explore more on viewModel and how is it working. For now, this will be the part 1. In the second part, we will explore the viewModel store owner provider factory and understand how is it working and try to understand and relate everything. Hope you enjoyed the details and the internals of the viewModel. Thank you for watching, and I'll see you next time. Bye bye.